Have you ever wanted to visualize a Raycast collision point, or perhaps have a circular health bar? Luckily, all of these and much more can be accomplished by using the draw function. Before we can create these features, we first need to understand how the draw function works and what we can use it for. The draw function is a built-in method within CanvasItem and therefore can only be called on anything extending CanvasItem. This function is called once when the node is instanced and whenever the update function is called. This means that if you want to run the draw function again, you have to call update. So what can you do inside this function? Well, let's start out by drawing a circle. To draw a circle, you'll need to define the center point of the circle, the radius, and the color. Since we are using the center point and color a lot in this script, I'm going to define them as constants. Now to draw the circle. Circles are helpful when representing points, but what if we wanted to draw a line from that point to, let's say, the mouse cursor? To draw a line, we need to define its two endpoints and its color. Since we want to connect this line from the previous point to the mouse position, I am going to use the center of the screen as the first point and the global mouse position as the second. We will also need our color constant from before. Now if we run the scene, it doesn't work. Why is this? If you remember from earlier in the tutorial, draw is only called when the node is ready or whenever update is called. Therefore, the line was drawn to the position of the mouse cursor a single time. To fix this, we must call the update function every frame. Let's try it again. Now, it works as expected. So how would we draw an arc? To draw an arc, we need to define a center, radius, starting and ending angle in radians, a point count, and a color. The point count combined with an ending angle allows us to draw some cool shapes, but we'll just start out with a simple arc. You might have noticed that draw circle always results in a fully shaded circle. If you want one that isn't shaded, you can use a 360-degree arc instead. What if you wanted a regular polygon? Try setting the point count to the number of sides plus 1 to draw one. If I set the point count to 7, we should get a regular hexagon. You can even draw a star by drawing 6 points around 720 degrees. You can even leverage this effect to create these weird cone-looking shapes. What if we wanted to create a less simple polygon? Draw colored polygon requires an array of points in the form of a pool vector 2 array and a color. I am going to define a constant for these points. Now we draw the polygon. If you wanted to add a color to each point, use draw polygon instead, and use pool color array instead of color. Now that we've explored the basics of the draw function, let's look at some possible applications for them. Let's create a simple paint program. We want this program to draw a circle at the position of the cursor whenever the user is holding the left mouse button. Since we only want the draw function to run whenever the left mouse button is held, we should only call update when it is held. We also have to draw the circle, so we'll add that to the draw function. Let's test it. As you can tell, it only draws one circle, so we need to use a for statement and an array to draw every circle ever drawn. When we test it again, it works as expected. Obviously, this is a bad drawing program. If you wanted to make a better one, I would recommend using the built-in setPixel function with an image and some interpolation. Sometimes you might want more debugging information than the console can provide. The draw function can be useful in visualizing information that would be unhelpful in text form. Let's use drawLine and drawCircle to visualize a raycast and its intersection point. Before we can visualize this information, we need to create it, or in other words, set up the scene. Start by creating a raycast with a cast2 value of 512 and move it to the center of the screen. This raycast will be rotated to point towards our cursor. Next, we'll need to create some objects for the ray to collide with, so create a static body 2D and add a sprite and collision shape 2D as children. Now give the sprite a texture and give the collision shape a shape. Duplicate and move these walls to your liking. Now that the scene is set up, we need to write the script. Start out by rotating the raycast to point in the direction of the cursor and running the draw function every frame. Now we need to visualize our data. First, draw a circle at the raycast's starting point. Then check if the raycast is actually colliding. If it is, then draw a circle at the collision point and a line between it and the starting point. If you run it, you will see that we have successfully visualized the raycast. Texture progress is great for creating rectangular health bars, but what if you wanted to create a circular one? This can be achieved using a combination of arcs. What are some parameters you would want this health bar to have? It would likely need a max value, the rotation of the bar when the value is 0, and of course, a value. Since the value of this health bar isn't being set by an outside source, I am using the mouse position. We also need to restrict the value from becoming larger than the max value or smaller than 0. Don't forget to call the update function every frame. First, we need to draw the parts of the health bar that are not dependent on value. Then we need to draw the parts of the health bar that do move, the red and green arcs. If you want to round out the edges of the arcs, you can draw circles there. Run it, and then move your mouse across the screen. you should see the bar begins to turn green as expected. And with that, we are done. Hopefully you learned something, and if you did, feel free to like and subscribe. If you have any questions, please leave them in the comments below the video. Thank you for watching.